When dealing with an 800 amp circuit consisting of 2-500 kcmil conductors per phase and neutral within a wireway and needing to extend it, splicing those conductors with 8 long barrel compression connectors is a viable approach. Firstly, prepare the conductors. This involves cutting the existing feeders to the desired length. Ensure you have enough length to work with for a proper splice. Then carefully strip the insulation from the ends of the conductors. The amount of insulation to remove will depend on the specific compression connectors you are using, so consult the manufacturer's instructions for the correct stripping length. Next, and importantly, clean the conductor surfaces. Use a wire brush or sandpaper to remove any oxidation, dirt, or other contaminants from the exposed conductor strands. This is critical for ensuring a good, low-resistance electrical connection. Secondly, install the compression connectors. Slide a compression connector onto each individual conductor, each 500 kcmil per phase and neutral. It is absolutely vital that the connector is the correct size for the conductor. Using an undersized or oversized connector can lead to a faulty connection, overheating, and potentially a fire hazard. Ensure the connector is fully seated onto the conductor, making full contact with the stripped portion. Thirdly, crimp the connectors. This is perhaps the most critical step in the entire process. Use a hydraulic crimping tool to crimp the compression connectors. The crimping tool should be compatible with the type and size of compression connectors you are using. Always follow the manufacturer's instructions for the crimping procedure. This will typically involve selecting the correct die size for the connector and applying the appropriate pressure or number of crimps. Ensure that the crimps are tight and secure. A loose or improperly crimped connection can lead to arcing, overheating, and failure of the circuit. After crimping, visually inspect the connection to ensure it looks solid and that the connector is firmly attached to the conductor. Fourthly, insulate the splices. This step is essential for safety and to prevent electrical hazards. Wrap the splices with electrical tape or heat shrink tubing to provide insulation. When using electrical tape, apply it in overlapping layers extending beyond the ends of the connector to completely cover the exposed conductor and connector barrel. Ensure the tape is tightly wrapped to provide a good seal against moisture and contaminants. Heat shrink tubing provides a more robust and professional-looking insulation. Slide the tubing over the splice before crimping and position it over the connector and heat it with a heat gun until it shrinks tightly around the splice. Remember to use heat shrink tubing that is rated for the voltage and temperature requirements of the circuit. By following these steps, you can successfully splice the 500 kcmil conductors using 8 long barrel compression connectors within the wireway. Remember, safety must always be paramount. Ensure that the connectors are properly crimped and insulated to maintain the integrity and safety of the circuit. It is important to understand that electrical codes and industry standards dictate acceptable practices. Always refer to the applicable electrical codes, industry standards, and manufacturer's instructions for specific requirements and guidance on electrical installation and splicing procedures. These resources will provide detailed information on conductor sizing, ampacity, splicing methods, and other critical aspects of electrical work. When working with electrical circuits, always de-energize the circuit before beginning any work. Verify that the circuit is de-energized using a voltage tester. Wear appropriate personal protective equipment such as safety glasses and insulated gloves. If you are not comfortable working with electrical circuits, consult a qualified electrician. Incorrectly installed electrical connections can be dangerous and can lead to serious injury or property damage. Consider the specific environment in which the wireway is installed. If the wireway is located in a wet or damp environment, use connectors and insulation that are rated for wet locations. If the wireway is located in a hazardous location, such as an area with flammable materials, use connectors and wiring methods that are approved for hazardous locations. The National Electrical Code, or NEC, provides detailed requirements for electrical installations, including conductor sizing, ampacity, and splicing methods. Familiarize yourself with the relevant sections of the NEC before beginning any electrical work. Some key NEC articles to consider are Article 110.3 covering examination, identification, installation, and use of equipment. Article 300 addressing wiring methods. Article 310 concerning conductors for general wiring. Article 314 focusing on outlet, device, pull, and junction boxes, conduit bodies, fittings, and handhole enclosures. Article 376 pertaining to metal wireways, and Article 392 addressing cable trays. Furthermore, always select connectors that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or Intertech. Listed connectors have been tested and certified to meet safety and performance standards. Using unlisted connectors can be dangerous and may violate electrical codes. Remember that proper planning is essential for a successful electrical project. Before beginning any work, carefully plan the layout of the circuit to determine the correct conductor sizes and select the appropriate connectors and wiring methods. A well-planned project will save time and money and will help to ensure safe and reliable electrical installation. Also note that regular inspection and maintenance of electrical connections are essential for ensuring the long-term reliability and safety of the electrical system. Periodically inspect the connections for signs of corrosion, looseness, or damage. Tighten any loose connections and replace any damaged connectors or wiring. Keep the wireway clean and free of debris to prevent overheating and other problems. Conductor ampacity refers to the maximum current that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by its size, insulation type, and installation conditions. The NEC provides tables that list the ampacities of various conductors under different conditions. When selecting conductors for circuit, it is important to choose conductors that have sufficient ampacity to carry the load. Overloaded conductors can overheat and cause a fire hazard. To determine the appropriate conductor size, calculate the total load on the circuit and then refer to the NEC ampacity tables. Remember to consider any applicable derating factors such as those for ambient temperature or multiple conductors in a raceway. For example, if the circuit will be operating in a high ambient temperature environment, the conductor ampacity may need to be derated to prevent overheating. Similarly, if multiple conductors are installed in the same raceway, the ampacity of each conductor may need to be derated to account for the increased heat generated by the conductors. When splicing conductors, it is important to maintain the ampacity of the original conductors. The splice should be as strong and conductive as the original conductors. Using undersized connectors or improperly installed splices can reduce the ampacity of the circuit and create a potential fire hazard. When making splices in a wireway, it is important to ensure that the wireway is large enough to accommodate the splices and the conductors. The NEC specifies the minimum size of wireways based on the number and size of conductors installed in the wireway. Overcrowded wireways can lead to overheating and difficulty in accessing the conductors for maintenance. Always follow the NEC requirements for wireway sizing to ensure a safe and code-compliant installation. Also, consider the voltage drop in the circuit. Voltage drop is the reduction in voltage that occurs along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction and can reduce the efficiency of the electrical system. The NEC recommends that the voltage drop in the branch circuit should not exceed 3% and that the voltage drop in a feeder should not exceed 5%. To minimize voltage drop, use conductors of sufficient size and minimize the length of the circuit. If the voltage drop is excessive, consider using larger conductors or increasing the voltage of the circuit. Lastly, ensure proper grounding. Grounding is an essential safety measure that helps to protect people from electric shock. A properly grounded electrical system provides a low resistance path for fault current to flow back to the source, causing the circuit breaker to trip and de-energize the circuit. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors. Always follow the NEC grounding requirements to ensure a safe and code-compliant installation. When splicing conductors, it is important to maintain the integrity of the grounding system. The grounding conductor should be spliced using the same methods and materials as the phase conductors. Ensure that the grounding conductor is securely connected to the equipment grounding bus in the panel board.